Hello, in this video I am going to tell you how we can solve this question number 24 of this book Engineering Circuit Analysis by Hayat Kemal Durbin from chapter 5, and it is related to source transformation. So question says that for this particular circuit, first transform both voltage source to current source, reduce the number of elements as much as possible, and then determine the voltage V3. What is V3? V3 is this, right? So over here, since we need to transform voltage source to current source and vice versa. So first of all, we can see this, right? These two, like this voltage and resistors, they are in series, so we can convert it into the current source in parallel. So if we do that, what we will get? We will get something like this is 6 ohm, right? And this is our current source, which is 4V3. This is 3 ohm plus minus, this is V3, 2 ohm and plus minus 2V3, right? Now for this, what will be the value of this current source? As per the rule, as per this rule that we discussed in the last video, that Vs is equals to ISR, or Is is equals to Vs upon R. Now over here, Vs is 2 volt, R is 6, so it is 1 by 3 ampere. So this current, it will be 1 by 3 ampere. Now similar to this, if we look at this part, these two, this dependent source and the resistance, they are also in series, so we can convert this also into parallel. So if I convert this into parallel, so the circuit will change. Like this 2 ohm resistor, it will come over here, right? And instead of this dependent source, voltage dependent source, we will be having a current source. And the value of this current source, again, like substituting in this formula using this, V is 2V3, R is 2, so we get V3, right? So simply it is V3, right? V3, yes. So okay, just a minute. No, it is of no use. Now over here I have converted this, but if I again relook of this circuit, then the over here, when I convert this voltage source into the current source, the benefit would be that after doing this, I will just combine these two current source into the single current source, right? But over here I do not have any such type of thing. So since I do not have any such type of things, so better is to keep this as it is. So I will not do any change. It will be 2V3. And over here in the next, like I will combine now 1 by 3 and this 4V3. Because if following the Ohm's law, if I following KCL at this node, since this current is coming down, this current is coming down, right? So means what I can do, I can, if I redraw this circuit like this, this is 1 by 3 ampere, this is 4V3, this is 6 ohm. I can simply replace the position of this resistor and this dependent source. How? Because they are this 3, 1 by 3, 6 ohm and 4 by 3 dependent current source are in parallel to each other, so we can simply interchange the positions, right? So I interchange the position, and now it is 3 ohm plus minus V3. It is, next resistance is 2 ohm, right? And then it is a voltage source plus minus 2V3, right? Now if I apply, like over here, one current is coming down, one current is coming in. So if I simply want what is the current that is coming like this, so over here these two can be combined. So if I combine this, my circuit, it will be something like this. 1 by 3 minus 4v3, right? And then resistance is 6 ohm, this is 3 ohm, this is 2 ohm, and this is plus minus 2v3, right? Now again, this current and resistor in parallel can be converted back to the voltage in series with the resistance. So it means I can redraw this circuit like this. I will convert it into the voltage source in series with the resistor 6 ohm, right? This is V3, 3 ohm, this is 2 ohm, this is plus minus 2v3, and this is the current. So this Vs, we know Vs is equal to Is into R. R is 6. So this will be our Vs. It will be Is is 1 by 3 minus 4v3 into 6. So we will get 2 minus 24v3. So this will be 2 minus 24v3. And now in this you can see that we have just a two voltage sources. We have two voltage sources, and let the current be I. So I over here, I over here, I over here. This is plus minus and V3. Right? Now applying the KVL, simply we will get like minus to plus. If I take minus to plus as negative, so minus 2 minus 24 V3 plus to minus will be plus 6I, then plus 3I, then plus 2I, then plus 2V3 equal to 0. And V3, what will be V3? V3 will be 3I. Right? Now solving these two equations, simply we will get I equals to 2 upon 89. Right? And once we get I, substituting the value of I in this V3, we will get 3 into 2 upon 89. It is 6 upon 89. So the answer, since we need to solve, what question says, we need to solve the value of V3. So V3 is 6 by 89. So you can see that with the help of the source transformation, we do not need high-end theorems like nodal or mesh. Simply by doing the transformations, by applying the KCL, and then by simply applying the KVL, we can determine the voltage across this 3 ohm resistor. So this is all from my side. So if you have any question, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.